Hi, everyone. Thanks for tuning in to the Printed Circuit podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. Everyone in the industry is wondering how AI will impact and potentially improve PCB design process. We're excited to be collaborating with an AI innovator, Celis. And in this episode, we'll talk with Antonio Becerra Esteban, Head of Customer Success at Celis. Thanks for being here, Antonio.
Hi, Steph. Happy to be here. Thanks for having me.
Antonio, can you give our audience a brief introduction of yourself and your role at Celis?
Yes. So my name is Antonio, and I'm working at Celis as the head of customer success. I joined the team almost 3 years ago as FAE. So I joined on the pre-sales side, and then over time I have migrated to the post-sales side. In the end, what we are doing, what my team is doing, is ensuring that all the users and customers have the necessary content, the necessary hints, helps, trainings to make sure that they can extract the maximum value from our solution.
Let's start off by getting to know Celis. So the first thing I want to ask is, can you tell the audience about Celis?
Yes, gladly. That's what I get paid for. So Celis is a startup from Munich in Germany. We have a wonderful solution, a web platform that enables engineers to technical requirements, capture them in the form of a block diagram, and then our AI searches for solutions, proposes solutions for all these blocks in the block diagram, taking into account their requirements. And then as a result of all the evaluation by the engineer, schematics are part of the output for different type of software footprint. So in the end, it's a startup that helps expedite the process from technical requirements to your first prototype.
Interesting. What inspired the founding of Celis? What problem in PCB design are you aiming to solve?
That is a great question that I've had one of our founders, Tobias Paul, talk about already quite some times. So all these originates when he's working on his master, and at the end of the master, you have to provide essentially like a report, right? You have been doing some research and you provide a whole report out of that. And part of his project was developing some control unit in the automotive industry, so for cars. Bavaria is very heavy on in the automotive industry. And he found that when it comes to code, there are many solutions that allow you to generate code almost without knowing how to code, right? Actually, I was last week in a fair in Rome, and I saw the solutions of easy code without code. You just describe high level what you need to do, and this program will output the software that you need. This does not exist for hardware. If you have a set of requirements for your PCB, good luck, right? You now have to go to Mouser, DigiKey, or to the elders of your company, if you're lucky and have people with a lot of experience, and then start researching, right? Start filtering specs so that you shortlist the hundreds of components you could get, then start reading data sheets to see if you can figure out, is this the right component? Is this that component that will solve the problem that I have? And then how do I implement it? Which configuration do I have to take into account? How can I capture it? Where do I get symbols, footprints, and whatnot? And this is the problem that he faced, essentially, dedicating hours and hours and hours of research to find some components, to find how to capture them on the schematic. And then, if you're lucky, they are all available, right? I raise my hand. I've been guilty of dedicating tons of hours of research to find the components, find the best component, and when I'm going to order it, obsolete or not recommended for new design. So back at square one. So that is the backstory in the end, how all this came to be.
I want to talk about the challenges that engineers are facing, not just engineers, but the small businesses as well. So from your experience, what are some of the biggest challenges engineers as well as the small businesses face in PCB design today?
There are different challenges. One very big challenge that I think is affecting us all is the knowledge gap. A lot of engineers are reaching the age of retirement and they're leaving the market, and younger engineers are entering the market, electronic engineers experience the frustration and the challenges of developing hardware. And many of them think, you know what, I'm going to go more into the code side of this industry than to the hardware side of this industry. So the split is changing. It's harder and harder to find electronic engineers that have experience in developing hardware, that are aware of all the challenges that appear: supply chain information, implementation, problems with mechanical issues that can happen, right? All certifications when you're developing hardware, choosing the wrong layer stack, and then having to go back after the first prototypes because, well, you have to redo everything. How cumbersome it is in the end, because it's very complex to produce a PCB. That adds to all the time consuming, right? That adds to all this complexity that honestly, small companies, it's very hard for it's complicated for them to survive in this environment. If you are a huge company with, I want to tell you, 10, 15, 20 developers.
Sure, that's the enterprise level. Yep.
Exactly. Your enterprise level, you have some wiggle room to adapt if things happen. If you are a company that has one or two engineers, one leaves, 50% of your workforce has left, right? And that means 50% of your capacity. If you have one person developing, you are very limited by the complexity of your projects. You might be able to output one or two boards a year. So mainly because you begin with the research, everything's super complex until you get the prototype. Then you start finding, you might find some issue, and every spin is time consuming. This is a trend in the industry, right? We're going through to more automation, more assistance, more information available for engineers to make better and more educated decisions. So the more tools engineers can have at their hand to develop, the easier these challenges will turn.
That's where you hear the phrase design resilience or supply chain resilience is intelligence at the point of design. And when you talk about challenges, how do these challenges affect the ability to innovate and stay competitive in the market?
Imagine if you have to invest. I have talked with so many engineers. You have to invest in finding solutions, finding a microcontroller. I'm going to make a very simple example. Find a microcontroller that delivers what you want. Then you're almost get branded with that microcontroller for your life, right? You're used to work with ST Micro. That's what you do. And if anything is to happen to the line of microcontrollers you work with, you have to start learning again. You have to start adapting again. I was talking with a friend that worked for a company. They had a almost like a PLC, essentially, right, receiving analog and digital signals and providing other outputs. And they were using a microcontroller that was almost decades old to repair and to produce new units. Instead of creating a new board and updating, they were fixed on, we need to even go to the end of the world to find more of these units, which is a huge time expenditure. You need to invest a lot of time. So this type of rigidity that hinders companies from adapting, coming with the next iteration. In the end, for every development, it can be hardware, it can be software, time is money. If you're a small company, you might not have the time or the money to innovate. You do what you know, you work with what you know. There might be a better solution out there, but in order to find it, you need to invest maybe 3 months, half a year. That solution is going to remain hidden for you.
I'm a big proponent for automation and machine learning and AI. So when we talk about automation and especially with the evolution of AI, now let's move on to the role of AI when you think about PCB design. AI is a hot topic in many industries. So how is AI specifically transforming the field of PCB design?
That's a great question. So you have to think that AI, many people perceive it almost as a threat. Will AI take my job, right? I'm sure AI is going to be transformative in all aspects of industry and life. So in PCB, when we talk PCB development, we can think of AI as a trusted companion, as someone that is going to suggest, is going to help you solve the problems. This point that I'm making is very important. It's going to solve the problems for you. It's going to help you solve the problems. Because In the end, there needs to be a human being behind evaluating the answers, evaluating the proposed solutions, and making the decisions. I would not want to be the engineer that trusts an AI to do, I was going to say complex, but it could be even a simple layout on a PCB, send it to the manufacturing, and then when it comes back and the thing doesn't work, I have to tell my boss, "Oh, the AI decided that for me," right? Because it's not the AI that is going to have to pay the price for that bad decision. So I think it's here clearly to stay, and it's here to boost the efficiency of the industry, boost the efficiency of those engineers that adopt it, that can help themselves getting answers from a data sheet, can help building models, can help getting suggestions to solve very complex problems, things that you could solve yourself in half a year, or you could use the power of artificial intelligence to solve them in a day or a week. In the end, that's what it's all about.
When you think about all the mundane tasks, especially from the role of an electrical engineer, there's a lot of research that, especially when you talk about reviewing the requirements that come in, and then how do you translate those requirements into viable solutions? When you think about putting a schematic together, and then especially transforming that schematic into a layout, there's a lot of details. There's a lot of things that have to take place behind the scenes, especially when you think about the role of the double E and all that he has to entail. There's a lot of mundane tasks, especially regarding scrubbing data sheets. It's a lot. Some of these data sheets, several hundred pages, especially if you think of a microcontroller or a processor. I can tell you at PCB West, AI was a hot topic, and it's a lot, especially when you think about engineers thinking that it's going to take their job. And like you said, I really love what you said about it's not. A human is going to have to control that power and utilize it. So when we think about the tangible effects, what are the tangible benefits engineers can expect when integrating AI into their design process?
You talked about mundane tasks, and I think that is one of the easiest to understand. Everyone has probably read here or there, LinkedIn or whatever, any post about, I asked ChatGPT, I had this problem, and I asked for a component recommendation, and I started having a conversation, and this is how I came to my solution. Think of precisely this capturing an AI that is oriented to electronics, that helps you capture the technical requirements of your project and offers you fitting solutions. This means that you're going to work way more efficiently on all these tasks of assembling your requirements, trying to find components for them, trying to implement them, try to distinguish, which is actually one of the most time consuming tasks, if the solution that you have in front of your eyes is the right one or not, if it will work or not. Adding information about being able to also base your information on supply chain information, cost optimization, the amount of things that happen actually early on. I'm not touching layout. I'm not even talking layout, right? The amount of things that happen only on the schematic are huge. All these little tasks, finding the models, downloading the models, capturing your schematic, connecting everything. Now, if you are able to capture your requirements, and AI provides you with solutions, you can check if they match, how do they match, if there are other requirements that maybe you can codify in a different manner, like imagine talk to an assistant, so that you can validate the solutions. And in the end, when you have found it, by the click of a button, you have a generated schematic where everything is connected according to the way you did it on the AI tool. That is amazing. That saves so much time in checking manual steps, checking information, click here, click there. The picture that I always have on my head is the picture of myself 5 years ago with tons of tabs on my Chrome browser, jumping, and in the end I have lost on which datasheet was I. Was I on supplier A or supplier B? That's the key. That is the biggest power of AI.
The requirements, getting them into the schematic is a challenge, especially when you talk about what solutions are available. How do you know, especially if you're a young engineer, you talked about the engineering gap with young engineers coming in. How do you get them to be utilized faster so they become an instant ROI for return on investment as an employee? And how do you get them up to speed faster? And I think with the implementation of AI, it allows that engineer, that young engineer, to be able to adapt quicker and faster and get up to speed and produce a product a lot faster than in years past. So, I want to move on to Celis's unique solution. What key features does Celis Design Platform offer that addresses the challenges we've discussed?
So the one that I would like to highlight, which I love, is Coobot. Coobot is our AI assistant. The journey on the Celis Design Platform begins, as I've said, with capturing your requirements, creating the block diagram. Then we click on solve or resolve, and the platform is going to check for pieces of circuitry, right? Little modules that are going to fit my requirements. If those requirements are functional requirements, specifications, or interfaces that this solution should have. I find it beautiful because it is an iterative process, which means that you can add and update your requirements as you discover more information in a very, very efficient way. So when I have solved, I have to start evaluating the results. I can go inside one of the blocks and start seeing all the solutions. These solutions, we call them cubos. Cubo, I'll say it's a Spanish word. I might be biased. It means bucket. So just as in a bucket, you can put all the necessary information, right, to distinguish, to classify, and determine which type of solution that is. The way I explain it is in 2 words. A Cubo is a digital data sheet that helps our AI distinguish solutions. To even make it faster for you and easier to understand, you can now interact with our AI assistant on our platform, Coobot, to the point that you can ask, hey, I'm searching for a solution that has 5 volts in, 3.3 volts out, and I need 200 milliamperes of current output. Or, hey, I'm searching for a wireless communication module for my IoT board or for my industrial board. I need to have, Zigbee or this particular solution. I can be very specific or I can be broader in my intention. And our assistant is going to take your query, your question, is going to check the solutions that are offered and is going to provide a suggestion. Then I, as a human, can open the suggestion. I will open the page of this Cube, or I will open the page of this digital data sheet where I'm going to see the application, the full schematic. I'm going to be able to see description, specifications, interfaces. I can see the BOM of this application. Even if I go further, if I click on the component, I'm going to be able to get to the page of the component, download the data sheet as the latest step of validation, which means that through Coobot, I am going to be able to navigate even faster through the proposed solutions. I'm going to be able to get super quick to the information. Coobot, on top of that, gives you, when an answer is provided, it normally gives you also where it comes from on the data sheet, for example, which means that, so I won't claim that data sheets are obsolete. I don't think that will be the case anytime soon, but you are going to end up reading data sheets, only that you're going to read those that really require your attention and not 40 of them so that you can filter out your results. And for this, Coobot is great. It's wonderful. I really enjoy talking to our assistant.
I seen the demo that you gave on how this flows, and I was so excited, but at the same time, I was a bit disappointed because I would have loved to have had this 20 years ago in my career, 30 years ago when I was starting and working with Double E's, because a lot of times I was asked to go research data sheets because the Double E had a stack of data sheets he's doing. So we're both trying to collaborate, and we spend a lot of our upfront engineering in doing that. And I could see where this is a huge time saver, and to have it at your fingertips. We as humans, there's that factor that you have to factor in, which is the human error of missing something. Whereas AI, it's a computer, it's computers operated, and it is so much power there.
That is where experience plays a role, right? Then human errors tend to, you could use your experience to overcome a typical human errors because you learn over time. Now, with the power of AI, you can help. I won't tell you fully substitute 30 years of PCB development, right? But as you mentioned before, you are going to be able to use the power of AI to come to speed sooner. So the ROI of a new hire, it's going to be much higher.
Exactly. And I think it also will allow not only to be able to engineer faster, design faster, but it'll allow you to remove a lot of the mundane tasks so that you could focus on truly the pure essence of design architecture when you think about designing an entire electronic system. I mentioned the demo, but I want to know, can you share any success stories or examples of how your solutions have positively impacted users?
Yes, we have actually quite some users that have texted us, thanking us, and it's not like for a specific solution, but it's for this um, peace of mind that they have a way of finding circuits there where they don't really have much idea. Because it could be that you are used to working with, say, microchip. You're used to working with microchip microcontrollers, right? You know all the microchip environment, and that's what you work with. But now you have to find some special sensor, some power filtering, some other type of solution that you're not so familiar with. You'll be happy with a solution. You only need to solve a certain problem. And we have had quite some users come to us. Actually, we were last weekend at the Maker Fair in Rome, and the amount of feedback that we got of people being amazed by what the platform does for them, I was very positively surprised. I was very pumped. It's always great, right, to hear it from everyone. All in all, it's not only that you are speeding up the process, but it's also, I mean, this is going to sound too fluffy, but it's almost like a peace of mind that you can have some help in a part of the PCB development that up until recently you were on your own.
I agree. I think, you mentioned earlier when you think about the young engineer starting or a small business unit, but I'm looking at it, for me, after 35 years in the industry, how I can utilize and harness this power with my experience and use it to my advantage. But the key here is be willing to trust and use that automation or that AI solution that's available. And I think that's the challenge. When we think about today's engineering teams and how they embrace automation, especially with the evolution of AI, it's going to be interesting to see who will embrace it and run with it and who will remain status quo. And then you got to think about what is the cost of doing nothing. Let's move on and talk about partnerships with Siemens EDA. How will integrating Celis AI-powered front end with Siemens PCB design tools benefit users, particularly those in the SMB market?
I would say the benefit is huge because now you don't only have a very powerful solution for PCB development as it is the Siemens EDA set of solutions, but it's also you have then when it comes before, right? When you enter the realm of layout, PCB development, I think it is easy to admit that Siemens EDA solutions are top. But before you get to the schematic, now what you can do with this integration is get to the schematic much faster. The boost in efficiency. You get open Siemens Connect, create a new project, and then start capturing the requirements. You are offered solutions. You are offered pieces of circuitry that are connected together according to what you're describing. And as the last step, once you have validated, you are now on your EDA tool from Siemens, you have your schematic that has been generated based on your input, based on your validation. Now you can take it from there. You go from your idea, from your prototype in your Siemens environment in hours, say in a day. It's amazing.
It's huge. Like I said, I seen the demo and I'm crazy excited about this. But let me ask you, what excites you most about this partnership and its potential to influence the industry?
Where do I start? Having a partnership with Siemens, it's huge. This means that such an actor in the industry as it is Siemens has seen and recognized the value of our tool, the value proposition of these things, of this startup in Munich, right? This means that we are going to be able to learn and develop so much better because in the end what we want is to offer value, to offer good solutions to our users, and this partnership it's going to help us gather very good input, and develop a tool in the direction of what the industry needs. That is marvelous.
I couldn't agree with you more. Now, let's focus on the long tail and SMB market. Why is it important to make advanced PCB design tools accessible to small business and independent engineers?
I think it all boils down to what you mentioned before, design resilience. If you don't have advanced tools, you get stuck in the past. Nowadays, if you don't jump on this train and start adopting advanced tools that boost your efficiency, that bring more information to you to make better decisions, that help you create better quality PCBs, help you check for, what do I tell you, emissions, right? All this is going to cost all these small businesses time and money. And this is the thing that most businesses have the least of, right? So it is strategically key for small businesses to embrace the power, the multiplying factor that advanced PCB development tools can provide for them, not only to be resilient, but to thrive in the end.
I agree with you. When I think about our evolution in this partnership and how the engineers are evolving, I think those that embrace it will definitely excel and lead the pack. Those that don't, frankly, they're going to get left behind. And when you think about the competitiveness of getting your product to market, if you're okay with coming second, third, or fourth in the industry, then continue what you're doing. Those that want to be the first to market or want to be successful, moving forward, AI is definitely embracing the solution is the key.
Absolutely. It's evolution. It's evolution, right? It's almost a matter of evolution. If you get behind, how behind is enough, right? How behind can I get to survive? That's a luxury I don't think almost anyone can afford, right? So getting your product to market as quick as possible is key in such a competitive environment as it is electronics development.
From my experience, especially, starting my career off in a small business and then in my evolution to the large enterprises, I can not only just see just a small business, but as well as the enterprise level, when you think about level loading resources and how to allocate and you get the most out of what limited resources you can with the shrinking budgets, the tight timelines. And I can see this solution and this collaboration between Celis and Siemens significantly being a positive impact to the industry. But I want to look ahead to March to 2025. Well, I know there are limits on what you can share with us, but what can our listeners look forward to with the up and coming fully integrated product?
They can look forward at an explosion in efficiency. They can look forward to way less frustration when developing their PCBs. They can look forward to having a Confluence page with requirements for the PCB and getting from there to the first routed PCB, the first routed layout, between the combination of the Celis design platform, giving the symbols, the schematics, and the footprints, and Siemens CDA providing the tools to route and define the PCB in record time. So they can look forward to talking to their solutions through Cubot, for example, right? They can look forward to getting their products to market in an absolute record-breaking time.
I couldn't agree with you more. How do you envision this product changing the daily workflows of engineers and designers?
The way I envision it is actually very, very positive. What I envision, what I see is a lot of happiness and way less frustration on their lives. Because if you don't need to spend your days reading data sheets, testing boards, realizing that you read something wrong, that you find, all this time that is invested in solving something with your analog brain, but using AI as a helper to make your daily life more comfortable, to make your daily life, you can focus more on what I believe probably all of us entered this world, right? Nobody entered this world because you like reading so much. You've read every book in the world. Now you have to go to the real deal. You have to read data sheets, right? So you entered this world because you are in one way or another a creative person. You like solving problems, and that is what I see, what I envision in the future. a revolution that will allow engineers to be creative and focus on what they really like.
It's definitely a challenge when you think about hashing through all the data sheets and then how do you interpret them? When you read something, it may be either a little cloudy or a little hazy, or technically it's hard, maybe a little hard to understand. But I think with AI, I think it will definitely help solve that problem and provide an amazing solution in an amazing shorter amount of time. And time is money, and that's the key. Before we wrap up, do you have any final thoughts or advice for engineers looking for a place to start when they're thinking of looking to do their first PCB design?
I would say, as a fresh engineer starting, plenty of content out there for you to learn and grow on. I would say explore. Don't be afraid of making mistakes. You have this life power of being young, having a lot of time ahead of you. Embrace the new solutions. Don't be afraid. Learn to use the new technologies. Use the AI. Master it. Use it to create your PCBs. Use it to create PCBs where you're going to make mistakes and you're going to burn them. That's also learning, right? But don't be afraid. Don't be afraid of using the resources you have at hand, because that is what is going to make them stick out in this market.
I love that phrase. Don't be afraid to use resources at hand, and that is the key. Is this is a huge resource. Use it to your advantage. And when I think about this opportunity, I think about establishing a better work-life balance. You could design faster, less time, and like I said, time is money, and time is important. And how you can gain back that time is key. And I think this is a great opportunity.
100%. If I have had a better work-life balance, I wouldn't have these gray hairs.
You and me both. Yeah, I got the silver on the side. So don't worry.
Had these happened before, maybe I wouldn't have such gray hair.
Yep. I know we're doing demos today for integrated product, but what are you most excited about when we think about that production release in 2025?
No, I'm super excited about seeing these. I mean, I won't see it on people's screens, right? But seeing this live, people clicking, people realizing the value of this solution, people really enjoying all the benefits of our collaboration, producing real PCBs with all the boost that AI can provide them. That I'm really looking forward to. I'm really looking forward to people using Siemens CDA saying, I created this board thanks to the collaboration between Sales and Siemens.
Awesome. Well, I think that's all we have time for today. So thanks for sharing your thoughts and insights on SELLUS. To our audience, continue to tune in for more trends, challenges, and opportunities across the printed circuit engineering industry.
Thank you. Bye-bye.